Hello all. Continuing on the journey for our study towards bioinformatics and also organic chemistry. Today we would be touching on amide coupling reaction visualization. My name is Abhishek Nandi. I am a PhD scholar. So let's start. So what we are doing? So we are building a web application using Streamlit and Python, of course, that serves as an educational and research tool for chemists, particularly in the field of organic chemistry. The primary objective of the application are visualization of chemical structures. The application allows users to enter SMILES, that is simplified molecular input line entry system strings, which are text-based representation of chemical structures. The code then uses the RDKit library to convert these strings into visual representations of the corresponding molecular structures. The feature is crucial for understanding and analyzing the molecular composition and layout of the chemical compounds. So as you can see, I have highlighted the major points of the amide coupling reactions. So you can see, like, we are simulating an amide coupling reaction, a fundamental chemical reaction in organic synthesis. The reaction typically involves the formation of amide bond between a carboxylic acid and an amine. The app allows us to use the input SMILES that we are putting in for both carboxylic acid and an amine. So chemical reaction, simulation and visualization. After the user inputs the SMILE strings for the two reactants, the app uses RDKit to simulate. RDKit is, as we know, like we were going through the details, like it consists of all the molecular compounds, and it's a very useful tool for people who want to code in Python, and it is usable in different kind of spheres also. So to simulate the amide coupling reaction, it generates the SMILE strings, also the images of it, and visual representations, allowing users to see the outcome of the chemical reaction. So what we are doing, it's an education tool, helps in better understanding complex chemical process, research and experimentation. Again, the key points as being highlighted to visualize the potential outcome of amide coupling reactions without the need for actual laboratory experiments. So what we are trying to do is simulate an organic chemistry environment using our programming approach for Python and see how the results look like. It can aid in hypothesis formation, reaction planning, and understanding molecular interaction in organic synthesis. So this is the major part of the code where we see the amide coupling reaction. The part that is much more important is the smarts, because when we are putting in these two molecules into the action, the smarts is the way how the molecule is being created. So as we see in the reaction 3, we are passing in the smarts, and from the products it's adding both of the reactants, that is molecule 1 and 2, the way I am just passing it on, and the resultant SMILE list is being created, and it iterates to the product and appended finally. Okay, so this part of the code is very important. So the function amide coupling is like a recipe that tells you how to mix two chemicals together to make a new one. Here is what each part does: getting the molecular ingredients ready, molecule 1 and molecule 2. You start with two chemicals represented by the SMILE string. These are unique codes for chemicals. The function turns these codes into a form that is into molecule 1 and 2. That is, we are passing in, when we are putting in the input, we are passing in as molecule 1 and molecule 2. We'll see it in action. So amide coupling reaction, the recipe starts, as we can see, the smart string is like a recipe for how to mix this chemical. It specifically describes an amide coupling reaction, which is a way to connect certain type of chemicals together, mixing the ingredients RxN3 and products. RxN3, that is the reaction 3, uses the recipe smarts to prepare for the mixing. That is, how do we add in both the molecules that are being passed. Then the function mixes molecule 1 and 2 together following the recipe, and finally we give the resulting SMILE list and visualize it accordingly. So that's the code link, but let's see it in action. So I have my IDE ready. I did my coding in Visual Studio Code. As you can see, the part of the code over here, we are passing in different smiles as a molecule like carboxylic acid and an amine, and after that this amide coupling function that we discussed is the major part where the entire action happens, and finally we are visualizing it. So let's see it in action. We'll just run through it. So again, Streamlit, then run. This is the c3.py file. I'll just make it run right now. We'll wait for it to come up. So in the meantime, what I have done is that I have kept some reactants handy so that I can show you the entire coupling reaction visualization. So let's pass in one of these, like acetic acid as a reactant 1 over here. I'm passing in as reactant 1, and now I am also passing in methylamine. So methylamine is a simple amine commonly used in chemical synthesis, and the acetic acid is a simple carboxylic acid often used in the standard in chemistry. So we start with some basic components itself. Now if I hit enter, you will see both of the molecules and finally the reactants adding together and how it gets to the final product that's been shown. So let's take example of other components too. We'll add up another carboxylic acid, benzoic acid itself, and just add in benzoic acid over here. Let's enter. You can see, like, with added components in the similar, if we are keeping it as methylamine, the reaction is giving us the result of this. Okay, so how cool it is to see the visualization, and the entire thing is done using Python itself, and it becomes very easier. So I'm trying to make bioinformatics, organic chemistry very easier for all of you who want to see how the things work in terms of programming. So I'm trying to learn and trying to showcase how the things work. So let's try out. Now I will take another compound, ethylamine. I will just add it as reactant 2. So this is reactant 2. I'll hit enter and you'll see the final reactant, both of them added, and how the product is being created. Okay, so that's the way you experiment a lot. Now I will change the reactants to aniline. Ethylamine is a primary amine with 2 carbon chain, so that is also a possibility. Let's see if it works or not. And just add it up and you see the final product. Again, let's give it a try with diethylamine and just use it over here and pass it diethylamine, and finally the product of it. So this application is very cool, and hopefully everybody will like it. The code is being shared over here. You can just take advantage of it, and I'm building on top of the entire bioinformatics things that I'm learning with organic compounds, chemistry, integrating it and making it much more easier for programming guys and getting a new leap of how programming can be used in organic chemistry also. Thank you and happy learning.